Good morning, everyone. It's a pleasure to be here today. I'm Frank Ouyang, and today I'm going to talk about geospatial analysis. From conservation to agriculture, transport to utilities, safety to urban planning, or resource to sustainability, analyzing your spatial data to gain insights and understanding problem is the core capability for us all in GIS. Our industries, methods, or approaches may vary in various ways or data types. By the core, many of us use our GIS to understand where to measure the real world, to see how places relate, to find the best locations or routes, to detect and quantify patterns, or to make predictions. And we are doing this with ArcGIS. And we have been doing this for a very long time. Throughout today, for example, you'll see spatial analysis or the results of spatial analysis in almost every presentation. And that's why ArcGIS is a comprehensive spatial analysis system. It needs to enable you to undertake your powerful analysis and data science workflows and to share your results across a broader range of audiences. The tools we are talking about are not limited just traditional spatial analysis built upon complex algorithms, but also GeoAI empowered by deep learning models. These spatial analysis methods are not new to GIS or ArcGIS, but we are seeing an expanded uptake in this and the capabilities in recent years. A large number of tools, models, and methods are provided across the ArcGIS platform, especially through ArcGIS Pro. There are hundreds of tools for you to choose from, over 200 tools in 24 toolsets for spatial analysis, and more than 90 raster functions for performing raster analysis. All these tools are grounded in scientific research, validated through industrial applications by users globally, and available across multiple platforms. With a heavy focus on research and innovations, more tools are made available and being enhanced or across more platforms beyond ArcGIS Pro into ArcGIS Online and ArcGIS Enterprise. Let's start with a quick look at our most recently added spatial analysis tools. Solar radiation modeling is for simulating the accumulating solar radiation in a particular location for a given duration. These tools support both Earth and Moon. It can be used for selecting locations for solar farm or commercial plantation that requires ample sunlight. Or it can even be used for finding a permanently shadow craters on the Moon for anyone who's looking for a nice and quiet place. The flood simulation tool is for reconstructing flood events at various duration and intensity. I want to spend some more time on this tool today and share a few highlights to you all. As you all know, flooding is becoming more often and more intense in Australia, and being able to understand the flood impacts can bring massive socio-economic benefits. This tool can be used for mapping flood risks, identify potentially assembly points, and understand the financial impacts of a potential flood event. Although it's not a replacement of a comprehensive hydrographic analysis, this tool can still provide valuable insights into the potential impacts of a flood. This tool is capable of calculating both the floodwater depths at various locations, as well as the flow direction and speed. The tool delivers the simulation on the fly, and being able to see the results in real time can improve the efficiency of your spatial analysis, and you don't need to wait for a long time before seeing the results. The simulation outcomes can also be checked across flood records in the history, and also the tool is available for simulating the storm surge for any coastal location and to identify high-risk areas. So far, we've been talking about individual spatial analysis tools. To create a workflow involving multiple tools, you can use Model Builder in ArcGIS Pro. It employs a low-code or no-code approach, and users don't have to write a full suite of Python commands to construct the workflow. The workflow itself is also be able to validate itself. And after that, you can publish the workflow as a geoprocessing service for more people to use. This service will allow users to run the tool hosted in your ArcGIS server to analyze their data. This reduces the need of a powerful machine on users' end. And the ArcGIS geoprocessing service is provided through a REST API, and therefore it can be used into other customized applications, such as geocoding service and printing service are the services that are used by many organizations every day. Later today, you'll see how data science team use platforms such as Databricks and Microsoft Fabric. GeoAnalytic engines brings S3 spatial analysis into these platforms so that they can take advantage of distributed processing capability that you already invested in. We mentioned earlier today that we are trying to make more tools available beyond ArcGIS Pro. ArcGIS Online is a good example, which now has more than 30 tools available that requires minimal software or hardware inputs. All you need is just a browser and some data in your ArcGIS Online. GeoAI capability is another important focus at the moment, as we are trying to make it more accessible and easier to use. Now I will pass on to Chris to continue the exciting exploration into GeoAI.
Thanks, Frank. So GeoAI being the intersection between artificial intelligence and spatial analysis. With AI advancing rapidly, GIS integrations are evolving just as quickly thanks to new developments across ArcGIS. We have modern GIS and computing power, which is more scalable and available than ever before. We have the ability to automate repetitive tasks, which saves time, ensures consistency, and frees resources across your organization. GeoAI democratizes analysis, making capabilities available to more users across your organization, not just data scientists. And finally, this allows us to quickly analyze larger data sets and more imagery to uncover patterns and get insights for our organization. At the core of this, we have GeoAI pre-trained deep learning models available to all users through Living Atlas. Some examples of this are building extraction, ship detection, solar panel detection, vegetation extraction in 3D, power lines from point clouds. There's over 90 pre-trained models across ArcGIS Living Atlas, which you can use from today. Let me give you an example of how this works in ArcGIS. You can use one of our pre-trained models, and in this example, I'll use the swimming pool pre-trained model, which might be helpful for local government enforcement teams. But what I'm about to show you is not specific to swimming pools. You could apply any of the pre-trained models to extract or detect and apply a classification scenario through this same workflow that I'm about to show. In this demonstration, I'll show you not only that ArcGIS provides us with the capabilities of GeoAI, but it couples these capabilities with other products, such as ArcGIS Workflow Manager and ArcGIS Survey 123 to create complete integrated GeoAI office-to-field workflows. In ArcGIS Pro, I use the detect objects using deep learning tool, and this is ready to use out of the box. I just define the area and let it run. This action then triggers a workflow in ArcGIS Workflow Manager, and it's important to note that this is one pool, my neighbour's pool, but I could deploy this across a town or a country and create hundreds of workflows for workers to go and inspect these pools if they're non-compliant. I'll let Workflow Manager do a quick analysis to determine the inspector area that intersects with the pool. And what this does is send an email, or in this case, a Teams message to the user, which allocates a task in Survey 123 using exactly the same capability that Matt just demonstrated at City of Sydney. And the inspector can go and complete that survey, submit the survey, and close the job. Survey 123 then sends an email to the staff in the organisation by email to indicate that the work has been done. In the demonstration, behind the scenes, Workflow Manager was orchestrating this process. This can work behind the scenes, or it can guide the user through with tooltips and actions to facilitate a workflow. The more I use the capabilities in Workflow Manager, the more I see them as an essential companion to GeoAI workflows. GeoAI can create lots and lots of data, and often we need to action that data with desktop analysis. We might need to enrich attributes, deploy a field worker, and this is where ArcGIS Workflow Manager comes in. ArcGIS Workflow Manager allows us to build and execute these workflows across ArcGIS using a drag and drop interface and even update data across external business systems such as ServiceNow. And that capability can be deployed across ArcGIS Online or ArcGIS Enterprise. I was really keen to see Matt's presentation and see a strong discussion about Survey 123 and put it in the limelight. I'm going to talk a little bit further about Survey 123 now and give an example of where GeoAI is being used within that app to enhance outcomes for organisations. I can load one of these deep learning models into Survey 123 to do the analysis on the fly within the app. In this example, I use Survey 123 to analyse plant health in real time using the deep learning models. This might be useful in situations where I need to empower users, unskilled staff, with insights into plant health without having to rely on secondary analysis. This simple example is using a pre-trained model of about 10,000 healthy and diseased tomato plants, and I've loaded that deep learning model into Survey 123. As a user, I simply, as we saw in the previous demonstration, capture the location. I can then capture the image of a tomato plant. The deep learning model works in the background and identifies that this is a tomato plant, and unfortunately for me, being my tomato plant, it might have early blight. We can add additional attributes. We can provide context to the user who's using it, just using some simple HTML and dependent fields, and then submit that securely to our ArcGIS portal. A quick word on unlocking these capabilities that Frank and I have discussed in ArcGIS. In ArcGIS Pro, you'll need a spatial analyst or image analyst extension. In ArcGIS Enterprise, you'll need an advanced server or an image server to access many of those advanced capabilities. If you're using ArcGIS Enterprise for Kubernetes, the ArcGIS image server can be configured with raster analytics as a premium capability. In Survey 123, you'll need a mobile worker user type, and in ArcGIS Online, for a lot of the analysis workflows, you'll need a professional plus user type. And as I mentioned, ArcGIS Workflow Manager is a separate license in ArcGIS Online and ArcGIS Enterprise. In our quick talk, we've explored the latest advancements in ArcGIS analysis, and it's clear that Esri are focused on expanding the range of pre-trained models available, and these models are evolving beyond just imagery and into vector data, into text recognition, into video. As we look ahead, AI assistance, as Simon demonstrated, will continue to enhance these tools, making advanced analysis more accessible to an even broader range of users across more organisations. The future of analysis in ArcGIS is smarter, faster, and more inclusive than ever before. If you want to chat about any of the things that we've discussed, Frank and I will be out on the stand at lunch and after the show. So thank you for listening.